When you buy an HVAC system, you are locking in a 15 to 20-year commitment. It becomes the single largest energy consumer in your building. You face an immediate choice: pay a low sticker price for older, legacy technology today, or spend thousands of dollars more upfront on a next-generation system. This graph maps 15-year expenses. Line A, the legacy system, curves sharply upward from energy waste and future regulatory repair costs. Traditional compressors operate at a fixed speed. They turn on at 100% capacity, blast cold air until the thermostat is satisfied, and then violently shut off. This chart shows the result. The jagged waveform represents massive spikes in electricity usage. Underneath it, you can see the room temperature constantly bouncing between uncomfortably cold and uncomfortably warm. The modern alternative is an inverter compressor powered by a variable frequency drive. Instead of stopping and starting, an inverter dynamically scales its speed to match the room's exact cooling load. As you see on the graph, the waveform stabilizes, keeping room temperature completely flat. Running continuously at a low speed uses far less power than constantly starting a heavy motor. This specific mechanical difference delivers up to 44% in annual energy savings. The compressor is designed exclusively to compress vapor. It relies entirely on an expansion valve to perfectly meter the incoming refrigerant and protect the hardware. If you ignore maintenance, liquid refrigerant can enter the vapor-only chamber. This triggers a flooded start, violently shattering the internal mechanics. The inverter premium pays for itself in massive efficiency gains, provided you strictly maintain the system to protect its precise physics. Beyond the compressor, you have an architectural choice: a traditional single-split system or a multi-split system. This top-down floor plan illustrates the core benefit of a multi-split. It offers true localized zoning. Cool air flows only into occupied spaces, like the living room and office. The bedrooms remain unconditioned, and your total energy use drops. The direct trade-off to this efficiency is extreme installation friction. Routing multiple lines throughout a building requires highly rigorous labor. The primary physics problem here is oil return. The compressor's lubricating oil mixes with the refrigerant, and it must physically travel back through long, complex piping. When lines are correctly sloped, oil flows smoothly. If an unskilled installer creates a poorly designed vertical curve, the oil gets trapped and begins to pool. As that trapped oil accumulates, the compressor is starved of lubrication. It overheats and seizes. Successful multi-split operation relies entirely on the contractor's mastery of fluid dynamics and precise pipe fitting. Sweeping environmental regulations have overtaken mechanical physics as the most urgent variable in the HVAC market. The current legacy standard refrigerant, R410A, is actively being targeted by regulators due to its high global warming potential. Under the AIM Act, the Environmental Protection Agency mandates a hard scheduled phase-down in the supply of these legacy refrigerants. This map from the TOM satellite shows the Antarctic ozone hole. Discoveries like this drove the Montreal Protocol and later the Kigali Amendment, providing the historical framework for today's policies. Buying a discounted R410A system today is an economic trap. As the phase-down continues, the scarcity of the refrigerant will make future leak repairs exorbitantly expensive. The industry solution is a transition to next-generation A2L refrigerants. These achieve regulatory compliance and guarantee that your system remains repairable in the future. A2Ls are officially classified as slightly flammable. In practice, strict new building codes and equipment sensors make them incredibly safe for residential use. Environmental regulations are direct, calculable financial liabilities. They dictate exactly what hardware you should install today. This flowchart maps the optimal system based entirely on your timeline and budget. If you are outfitting a short-term residence, a guest house, or a seasonal cabin, you fall into the category of the budget-conscious pragmatist. Because you run the system infrequently, the 15-year return on investment for an inverter will never materialize. A standard single-split or window unit is your safest, lowest-risk choice. If you are outfitting a primary residence or business for the next decade, you are a long-term optimizer. In this scenario, buying a fixed-speed system with legacy R410A refrigerant is a financial trap. You must absorb the steep upfront cost of a multi-split inverter system running on an A2L refrigerant. This secures your 44% efficiency gain, enables localized zoning, and buys you regulatory immunity. Prioritize a contractor with the technical mastery to ensure your 15-year investment actually survives over the specific logo on the outdoor unit.